This is Chapter 9, Part 1. Chapter 9, Part 1. I hope you can hear me okay. Can you hear me? I hope so. Well, anyway, let's try it. We're going to start with number 1, testing for symmetry with respect to the axes. Let's try the x-axis first. To test for the x-axis, you negate the y. And you'd have minus 5y equals x squared plus 3. And these two equations are not equivalent, so you would say the x-axis does not have x-axis symmetry. Okay, now let's test it for y-axis symmetry. So let's get rid of that. Okay, to test it for y-axis symmetry, you negate the x. And that becomes 5y equals x squared plus 3. As you square negative, it becomes positive. And these two equations are equivalent. So y-axis symmetry, yes. Now let's take a look at number 3. Let's do x-axis first. Negate the y. And when you raise negative to an even power like 4, it becomes positive. So this equation is equivalent to the original. So there's a yes on x-axis symmetry. Now for y-axis symmetry, you negate the x. And this would be 2x to the 6th plus 4 equals y to the 4th, which is equivalent to the original. So for y-axis, you also have a yes. For number 5, we'll do x-axis first. And you negate the y. So 3x minus 6 equals minus 4y. These two equations are not equivalent, so there is no x-axis symmetry. We'll do y-axis symmetry now. For that, you negate the x. So minus 3x minus 6 equals 4y. These two equations are not equivalent. So there's a no on the y-axis symmetry. Number 7. We'll do x-axis first. So you negate the y. X cubed then equals 2y squared. These are equivalent. So for x-axis, we have symmetry. How about y-axis? For y-axis, you negate the x. And when you cube a negative, you get a negative. These two equations are not equivalent. So for y-axis, it's a no. Okay. Let's see what's next. Origin symmetry. All right, we got a test for origin symmetry. Number 13, you negate the x and the y. And that would be 3y squared minus 4x squared equals 4. Same as the original equation. So there is yes on origin symmetry for this one. For number 17, we got to negate the x and the y. And if we multiply both sides by negative y, we'd have 4 times negative x times negative y equals 6. Well, negative times a negative is positive. And if we had multiplied both sides of this equation by y, we'd have 4xy equals 6. They're equivalent. So there's a yes on 17. For 19, negate the x and negate the y. This would be 4x squared minus 5x equals minus 3y. These two are not equivalent. So no origin symmetry here. And number 21, negate the y and negate the x. Well, the absolute value of a negative is positive. And these two aren't equivalent. So there's no origin symmetry on that one. Now remember, a function that is symmetric to the y-axis is called even. And a curve that is symmetric to the origin is called odd. Origin, odd. Y-axis, even. So, good news. A curve can either be even or neither, but never just two of those. So if we find one, we don't have to find the other. Anyway, for number 22, we want to test it for even. So negate the x. Let's think of this as y. So negating the x, we'd have y equals 2x squared minus 4x. They're not the same. So what do we say? We say it is not even. Oops. Okay, now let's test it for odd. Negate the y and the x. So this would be minus y equals 2x squared minus 4x. Not equivalent. So it's not odd. And we already figured it's not even. So it's neither. So number 22 is neither. Neither even nor odd. Let's take a look at number 24. Think of f of x as y. So we're going to test it for even first, which means y-axis symmetry. That means you negate the x. Well, that's going to equal the absolute value of 3x. They're equivalent. Therefore, this is even. You don't have to check it for odd. For 25, let's check it for even. And think of f of x as y, so that means y-axis, negate the x. So y equals minus x minus 1 over x. Not equivalent. So it's not even. To test it for odd, we negate the x and the y. So minus y equals minus x minus 1 over x. If we had multiplied both sides of that equation by a negative 1, we'd have it. It is odd. Number 27. Well, this is easy. F of x equals 7 is a horizontal line. It's certainly symmetric to the y-axis. Therefore, it's even. (29) is even, because it's symmetric to the y-axis. 30 is odd, because it's symmetric to the origin. 33 is neither, because it's not symmetric to the y-axis nor the origin. 34 is odd, because it's symmetric to the origin. Okay, let's go to 9.2. Number 1. Well, first of all, you got to remember that the absolute value graph looks like, let's see, let's put it temporarily over here. The absolute value. The vertex is at the origin. It goes through 1, 1, and negative 1, 1, 2, 2, and negative 2, 2, and countless other points. So the graph looks like that. Well, what are we going to do to this graph to get this one? We're going to move it up 3. So the vertex will be here now. Instead of 1, 1, will be at 1, 4. Instead of negative 1, 1, we'll be at negative 1, 4. We need at least 3 points. The vertex, 1 to the right, and 1 to the left. So what are we going to do to this red graph number 2? We got to move it down. I'll do it in a different color then. It's going to move down 4. The vertex will be at 0, negative 4. And we'll have a point here and a point there. So it's the blue one. Number 9. Again, let's remember what the absolute value looks like. We'll put it right here as a reference. Remember, it's V-shaped, not U-shaped. Well, in number 9, what's going to happen? We're going to have to move the blue graph to the right 4. And what's going to happen to the blue graph in number 11? Well, it's going to have to move to the left 3. In number 15, we're going to be doing a couple of things. But again, we need a reference. So let's put the absolute value of x right here for a moment. So the issue is, what are we going to do to that red graph? Well, we're going to have to move that red graph to the left 2. And down 4. So if we move it to the left 2, down 4, the vertex will now be right here. Okay, that ends 9, 2. So now let's go to 9, 3. Okay, again we need to remember what the absolute value graph looks like, so let's put it right here. V-shaped graph. So what's happening to that graph in number 1? It's going to have a vertical stretch by 2. So all the y's will be 2 times as great. Well, 0, 0 will still be there. But instead of 1, 1, we'll have 1, 2. And instead of negative 1, 1, we'll have negative 1, 2. In number 4, what's happening to the red graph? Well, it'll be a vertical shrink by 1/2. Zero, 0 will still be there. And instead of 1, 1, we'd have 1 comma half. Instead of negative 1, 1, we'd have negative 1 comma half. Whoops. There. What would be better is if we had used, say, instead of 1, 1, instead of 1, 1 and negative 1, 1, we had used 2, 2 and negative 2, 2. And that would make it, instead of 2, 2, 2 comma 1. Instead of negative 2, 2, it would be negative 2 comma 1. Number 5. Well, again, the absolute value of x looks like this. So what's happening to that graph in number 5? Well, a couple things are happening. The y's are multiplied by 5 and negative 1. Well, you can say just by negative 5. So instead of 1, 1, we'd have 1, negative 5. Instead of negative 1, 1, we'd have negative 1, negative 5. 0, 0 would still be unchanged. So here we have a vertical stretch by 5 and reflected over the x-axis. Okay, what happens when you multiply the inside? Well, again, we need the absolute value of x again. So what's happening in number 13? Well, when you multiply the x by 2, you're actually dividing them by 2. So instead of 2, 2, you're going to divide the x by 2, which makes it 1 comma 2. Instead of negative 2 comma 2, you're going to have negative 1 comma 2. And 0, 0 will remain unchanged. Okay, let's go to the adapted one. This is the same handout 9.3. I just structured it so we'd always see our model. The model graph being what we have right there. Well, it'd be a good idea to know these points. This is negative 5 comma 4. This is 0 comma negative 2. This is 3, 3. And this is 7, 0. Oops, that's 4, 3, excuse me. And this is 7, 0. So what's happening to that graph in number 7? All the y's are being multiplied by 2. So, negative 5 comma 8. And 0 comma negative 4. And 4 comma 6. And 7 comma 0. There's number 7. Okay, number 10. Let's identify these points again. This is negative 5 comma 4. 0 comma negative 2. 4, 3. 7, 0. Number 10, we're multiplying the y's by negative 2. So we would have negative 5 comma 8, excuse me, negative 8. And instead of 0, negative 2, we'd have 0 comma 4. And 4 comma negative 6. And 7 comma 0. Here we got a vertical stretch by 2 and a reflection around the x-axis. Number 11. We need those points back. Negative 5 comma 4, 0 comma negative 2, 4 comma 3, 7 comma 0. So what's happening in number 11? All the y's are multiplied by a half. So negative 5 comma 2. 0 comma negative 1. 4 comma 1 and a half, or 3 halves, and 7 comma 0. This is a vertical shrink by 1/2. Well, this one's definitely different. All right, so this is negative 5, 4, 0, negative 2, 4, 3, 7, 0. Oops, 0. Well, when you multiply the inside by negative 2, you're actually dividing your x's by negative 2. So negative 5, 4 becomes positive 5 halves, comma, 4. It's 2.5, comma, 4. And 0, negative 2 would still be 0, negative 2. Remember, we're dividing our x's by negative 2. 4, comma, 3 would become negative 2, comma, 3. And 7, comma, 0 would become negative 7 halves, comma, 0. Oops. Let's see. So this is a horizontal shrink by 2 and a reflection around the y-axis. All right, let's get those points back. Negative 5, comma, 4, 0, comma, negative 2, 4, comma, 3, 7, comma, 0. Well, what's happening in number 21? Well, you're adding 2 to all the y's. Everything's getting moved up 2. So we're going to have negative 5, comma, 6. Instead of 0, negative 2, we'll have 0, comma, 0. Instead of 4, 3, we'll have 4, comma, 5. And instead of 7, 0, we'll have 7, comma, 2. This is a vertical shift up 2. Now what's happening in number 22? Well, we're going to take the original graph and move it to the right 1. So all the x's will be 1 greater. So negative 5, 4 will now be negative 4, 4. And 0, negative 2 will be 1, negative 2. And 4, 3 will now be 5, 3. And 7, 0 will now be 8, 0. This is a horizontal shift right. Oops, I was going to write 2, right 1. Well, we're going to do this one. We'll skip number 23. So what's happening here? Well, a couple things are happening in number 24. All the y's are being multiplied by -2, and all the x's are going to increase by 3. So -5, 4, let's do a different color then. So let's take care of the y's first. For -5, 4, the y will become -8. For 0, -2, the y will become 4. For 4, 3, the y will become -6. And for 7, 0, the y will still be 0. Now for the x's, they're all going to increase by 3. So -5, 4, that would become -2, -8. And for 0, -2, that would be now 3, 4. And for 4, 3, that would now be 7, -6. And for 7, 0, that would be 10, 0. Now we're ready. -2, -8. And 3, 4. And 7, -6. Let's see. Yes, 7, -6. And then 10, 0. Let's see. Let's magnify this, make it a little easier to see. A little crooked on that last one. There. So there were 3 things that happened here. There was a vertical stretch by 2. It was reflected over the x-axis, and it was shifted. It was a horizontal shift to the right 3. That's it.